Hello, my dear learners. Welcome you to this session. In this session, we will discuss some multiple choice question. It is electricity chapter and chapter 12. You are very familiar about that. The topic electricity. You know very well, electricity is a source of energy that has made our life comfortable and easy. We depend on the electricity for almost all activities in our day-to-day life. Now on the screen you see, first of all you read the question statement. A cell, here is the cell also called as a simple battery. A resistor, here is a resistor, you know very well. A key is here. Ammeter, that is ammeter, right? The three circuit is here. We will try to understand this statement and try to give the answer. The current recorded in the ammeter will be what? Maximum in 1, maximum in 2, maximum in 3, and the same in all cases, right? So we will go through the option D. Then how? Why you will take the option D? The same in all cases. Why? There is no charge in any other circuit, hence current will same in all circuit. If there is no charge, then it is very clear that the current will be same in all circuits, right? The second question you see on the screen, that is here three option is here. In the following circuit, heat produced in the resistor of combination of resistor connected to a 12-volt battery will be what? You see here it is a battery or cell, whatever that you can keep in mind. Here is the resistance. Here is the it is a individual resistance. Here is the two resistance. It is connected in series. Here is the two resistance. It is connected in parallel. Right. Now come to the option what given here. In S option, same in all cases. Same in all cases. You see minimum in case 1, maximum in case 2, and the last option we have maximum in case 3. Here we will go through that the option number C, and we will let in this question you see maximum in case 2. What here? The resistance connected in series. Now let's see. Yes, here two transistors are in series. Total resistance will be less than individual resistance. Two transistors written. Here you can write resistance. Make correction. Total resistance will be less than the individual resistance as they are connected parallel, right? Higher resistance produce more heat, hence option C is there. If the resistance connected in series, it's produce high heat, right? The next you see electrical resistivity of given metallic wire depends upon its length, its thickness, its shape, and the fourth, nature of material. You always try to be give the close answer, right? All are the factors, its length, thickness, and shapes, and nature of material of the resistance of the electrical wire. So you should give the answer very close, right? D will be the answer. Nature of the material, right? Nature of the material, metallic wire electrical resistivity depends upon. A current of 1 ampere is drawn by a filament. The fourth question I am reading here. A current of 1 ampere is drawn by a filament of an electric bulb. Number of electrons passing through a cross section of the filament in 16 seconds would be roughly. Time is given, you know very well, 16 seconds. Here is the I is given what? 1 ampere. And what need to find? And we will go through the answer. I have to choose an A, and let's see that how we will be choose the A. You know very well the relation between charge and time and current. I equal to Q by T, Q equal to I into T. Q equal to 1 into 16. Electric is 1 ampere, no? So we multiply. So Q, you can write Q is the unit charge equal to 16Q, and Q equal to also no NE. N equal to what? 16 by that. Say 1.6 into 10 to the power minus 19, and when you write here um, 10 16, right? Okay, you see in the below, you see here n equal to 10 to the power 10 19, then the electrons will be what? The number of electrons flowing is 10 to the power 20 electrons. So I have chosen the option number A, right? Here is the important current flowing and second, and then the relation is required to know, right? It's very important question. Now let's see that the next slide, right? You see the four circuit is given, right? Identify the circuit in which electrical components have been properly connected. Here the sign minus and plus is very important when you are doing the such type of question. You see here ammeter and voltmeter connected in series, it is wrong. Here we can consider this one, voltmeter and resistance are connected in a parallel, so and ammeter also in the resistance and ammeter in the same line, right? And here is the cell minus and plus, here is the switch, right? And on one point I want to introduce you, always a switch connected in the negative charge path, right? Here is the, you see here, here is ammeter parallel to resistance, it is wrong. Here is the resistance and voltmeter connected parallelly, and ammeter is connected here. Here is the negative sign and here is the positive sign, so it is also wrong. We go through the option 2. Now let's see that we have an option A equal to 1, not B equal to 2. Yes, we go through the 2, and C is not, D is not. We have seen no above. Now you see. Now let's see that what is the maximum resistance which can be made using 5 resistor each of 1 by 5 ohm. A equal to 1 by 5 ohm, B equal to 10 ohm, C equal to 5 ohm, 1 equal to, the answer is showing here 1 ohm. Why? You see maximum resistance which can be made using 5 resistor each. Why? If the resistor connected in the series, maximum resistance is obtained when resistor are connected in series, right? So we go through the 1 ohm. The point is very important to keep in mind. Then you are able to solve the question. Then you see here, if the resistor are connected in series, how can we write? R equal to 1 R1 plus R2 plus R3 dot dot dot, whatever the how many resistance are given. And the R equal to what can we write? 1 plus 5, 1 plus 5, 1 plus 5, right? How many times you write? So it is very important. 5 times written, 1 by 5, you know very well how to add it, 5 by 5. So always maximum current, maximum resistance in connected in series connection, right? The second next question for 7. What is the minimum resistance which can be made using 5 resistor each of 1 by 5? It is a vice versa, it is a opposite of the, we have a two connection, series connection and parallel connection. So series connection having a maximum resistance, so it's very clear that minimum resistance we can get from the 5 resistor connected in parallel, right? So how can we find it? You see here, what is the minimum resistance? 1 by 5, 1 by 25, 1 by 10 at D equal to 25 ohm. So we go through the option number B. No, option number B you go. Here is given B, right? 1 by 25. You know very well 1 by R equal to what? 1 by R1 plus 1 by R2, right? 5 register is mentioned here. I always tell you, you read the statement very carefully, then you are able to give the correct answer. It is very important playing role in your board examination, right? It is very important, right? You know very well about that. Explanation here you can see. Now, minimum resistance is obtained when resistors are connected parallel. I have explained. Next question you see. Here the proper representation of series combination of cell. Now this is question on cells, right? Here is the cell, right? One is here, this one, this one, this one. See carefully and try to A 1 connected, no. B 2, no. C 3, no. D 4, no. So what will be the answer? Let's see. We go through the option A and it is best option for satisfying the condition which given in your question. Let's see what written in the question. The proper representation of series combination of cells obtaining maximum potential. When you get the maximum potential, you see here, right? It is connected, it is connected, it is connected, right? So first of all it is a positive, then a negative, then positive, negative and positive, negative and positive, negative and positive, negative and positive, right? You see here negative and positive, here is no connection like this one. So how can we go? This is negative, negative, so it is wrong. It is also wrong, not connected. It will be considered, but here what? Two negative sign is here. It is H, so it is wrong. So we go through the one option, right? Now let's see explanation. Here positive terminal of the next cell is adjacent to negative terminal. Just I have a click on that, right? The next question you see, which of the following represent voltage, work done by the current into time, work done into charge, work done into time by current, work done into charge into time, right? We go through the option number 1, A, that is what? Voltage equal to work done by current and time. It is the ratio of work done and product of current and time. So voltage represent always this one, right? We go through the A. The next question on your screen you see a cylindrical conductor of length 1 and uniform area of cross section A has a resistance R. Another conductor of length 21 and resistance R of the same material has area of cross section, right? So what we will find? So we go to find the current, right? So A is A by 2, B is 3 by A by 2, and C 2A and D is 3. So ampere, half ampere, 3 by 2 ampere, here is a 2 ampere, here is 3 ampere. So the numerical values are given, you are able to find this one. So I choose the C option. Let's see the what is the explanation about that. You see here, right? Here P equal to RA by L when length doubled. What you get? P equal to RA by 2L and here is RA by L. P here equation 1 and we when you double it you get P RA by 2L. So we can write RA by 12. You see RA and RA cancel. So you see how you have that one. RL by A, RA by L equal to RA by 2L. RA cancel, RA cancel, right? Well, L will be what? Am I right or wrong? So C, A equal to 2L. A equal to 2L. No problem. So we go through that ampere, 2 ampere. The next question 11, you see here is a student carry out an experiment and plots the voltage and current graph of three samples of nichrome wire with the resistance R1, R2, R3 respectively. Which of the following is true? Here is the ampere, ampere always in a y-axis and volt always in a x-axis. You see R1, R2, R3 like this one, and what would be there? Resistance, all the resistance are equal? No. R1 is greater than R2 and greater than R3? No. R3 greater than R2 greater than R1? No. R2 greater than R3 greater than R1. So let's see what would be the answer for that. Resistance situation is what? So you see solution C. R3 always greater than R2. Here is the C option. So C, we go through the R. This option R3 greater than R2 greater than R1. When it is an voltage current graph of three samples of nichrome wire, which has a resistance 1, resistance 2, resistance 3. So here nichrome wire you are using, and you can go through the R3 always greater than R2 and R2 greater than R1. Current flowing inversely proportional to resistance. You know very well current flow is inversely proportional to resistance. And can you write I equal to proportional? Highest resistance will show less flow of current, hence answer C. Highest resistance when you fill. Yes, the current less flow in the wire, then resistance is high. We can imagine, we can know, you know very well. Now let's see the 12 number question. If the current I through a resistor is increased by 100%, assume that temperature remains unchanged. The point is here. Now very easy. You see, the current through a resistor is increased by 100%. The increase in power dissipated will be what? 100%, 200%, 300%, 400%, 300%. Right? Resistor increase 100%. The current here I will be 300%. How? You can see here. Heat generated by a resistor is directly proportional to square of current. Hence, when current becomes double, dissipation of heat will be multiplied by 2 equal to 4. This means there will be an increase 300%. Right? The next question 13, resistivity does not change if the material is changed. The resistivity does not change. Material change, temperature change, shape of resistor change, both material and temperature are changed. So we go through the shape of resistor change. Shape of resistor change. It not affect on that. So see the shape of resistor is changed. Right? Resistivity does not change if the shape of resistor is changed. It is very important question. I think that it will be asked. An electric circuit 3 incandescent bulb ABC of rating 12, 40 watt, 60 watt, 100 watt respectively are connected in parallel to an electric source. Which of the following likely to be happen regarding their brightness? Brightness of all bulbs will be the same. Brightness of bulb A will be maximum, brightness of B will be more than A, brightness of C will be less than that of B. Now see what is the answer. Brightness of bulb B will be more than A. You see, we go through the option B or C. So we go through the option C. Brightness of bulb B will be more than that of A. How? You can see bulbs are connected in parallel. So resistance of combination would be less than the arithmetic sum of resistance of all the bulbs. Bulbs are connected in parallel. So resistance of combination would be less than arithmetic sum of resistance of all the bulbs. So there will be no negative effect on flow of current. As a result, bulbs would glow according to their wattage. Here in the parallel, no, so bulb will be glow according to their wattage, right? You see, A is 40 watt, B is 60 watt, and C is 100 watt, right? So you know very well. Wattage is very important. And in an electric circuit, two resistors, 2 ohm, 4 ohm are connected in series to a 6-volt battery. The heat dissipated by the 4 ohm resistor in 5 seconds will be what? 5 joule, 10 joule, 20 joule, 30 joule. So let's see and we recall the concept which we have learned in previous. Now we go through the C option 20 joule. How? You see now. Equivalent resistance of circuit is R equal to 6 ohm. Current will be V by R, that is 1 ampere. So the heat dissipated by 4 ohm resistor is H equal to I RT, that is 20 joule. The next question 16. An electric kettle consumes 1 kilowatt of electric power when operated at 220 volt. A fuse wire of what rating must be used for it? Here is asking the fuse wire, right? 1 ampere we can use, 2 ampere we can use, 4 ampere we can use, 5 ampere. So let's see. Concept is very important, my dear learners. Then you are able to do the such type of question. We go through the option number D, 5 ampere. How it will take. So go through the explanation. You know P equal to V into I. Very good. 1000 watt equal to 220 volt into current. Then I equal to what, my dear? 1000 watt by 220 volt. You can cancel it, right? Then we will divide 100 by 22. We get what? 4.54 ampere. And ampere equal to, you know, W by V. That is approx 4.5, that means 0.5. You recall the estimation. It is tends to 5 ampere. It is equal to 5 ampere. We can take pole very close, right? So it would be the 5 ampere. So answer will be 5 ampere. The such type of question will be asked from you, and I hope that you will do better in your exam.